Logitech have been in the design and manufacture of a wide range of versatile systems for trimming, lapping and polishing in the preparation of geological thin sections for over 50 years. We bring a wealth of knowledge and problem-solving skills in producing high-quality geological thin or ultra-thin sections of rock, coal, concrete, soils and fluid inclusions. By working with you, we can assist you in integrating the relevant processes and systems to meet your material processing requirements, such as weekly output, surface finish, and geometric tolerances. Generally, standard thin section production can be broken down into the following basic steps: slabbing and trimming of field specifications, impregnating soft, porous or friable materials, first phase lapping of cut material, preparation of slides to uniform thickness, bonding specimens to prepared slides, thinning bonded specimen, lapping specimen to chosen thickness, polishing specimens. We provide a quick and effective route to complete success with our full-service thin section preparation system solutions. For the first stage, a section of sample must be cut for processing. The GTS1 thin section cut-off and trim saw is ideal for geological applications. Allows users to cut hard or soft rocks, concretes or cements with equally high efficiency. The GTS1 can be used for both cutting bulk rock size and for thinning the slide-mounted rock chips prior to final lapping. Bulk materials can be easily handled by mounting on the sample table or fed through the blade by hand. If a material is too soft, porous or friable in their raw state, the material must be impregnated with a synthetic resin before it is processed. The Logitech IU30 impregnation unit is designed to encapsulate and impregnate specimens with synthetic Logitech resins, allowing for safe processing without sample damage. The IU30 allows both sample and resin to be evacuated separately and enables resin to be delivered to the sample while both remain under vacuum. Admission of air to the sample chamber then causes the specimen to be impregnated with resin under atmospheric pressure. The IU30 is ideal for impregnating large samples and multiple small samples. It is the ideal solution for laboratories with a high volume requirement for impregnated materials. It is a self-contained unit and has been designed to meet the needs of researchers. The first stage of lapping is carried out on the PM6 precision lapping and polishing system. The samples are placed inside the steel retaining ring with a pressure block and loading weight placed on top. This is then mounted onto a cast iron lapping plate for processing. This has a rotational plate speed of up to 100 RPM with the aid of an abrasive slurry. Process conditions are set via the graphical user interface on the PM6. The user can easily control the amount of abrasive delivered to the plate via the metered abrasive feed unit. A targeted removal rate can also be set that will automatically stop the process when this has been reached. This avoids sample overprocessing. The PM6 system allows operators to produce around 100 standard thin sections per week. Using a single station with optional autolap, the PM6 makes use of the PLJ2 precision lapping jigs to produce sections of repeatable and uniform thickness. Intelligent features of the PM6, including recipe mode and automatic plate flatness control, allow for easy process repeatability. This enables operators to produce high-quality thin sections every process. Before the specimen can be mounted to the slides for further processing, the slide must first be prepared to the required uniform thickness for sample consistency. The slides are mounted onto a Logitech precision jig via a vacuum. The jig is then mounted upon the machine and the slides are lapped to the required thickness. A Logitech Bluetooth-enabled micrometer is used to measure the thickness of the slides. Bluetooth feedback allows the data to be recorded. The production of thin and ultra-thin sections of materials requires that the sample material be fixed to the prepared microscope slides. It is important that the orientation of the sample bond slide is controlled for achieving optimum sample thickness control and parallelism. Zero bonding and controlled thickness bonding are two important techniques developed by Logitech to enable bond orientation and thickness to be controlled easily with great precision. The sample and slide is assembled using epoxy resin and is placed within the jig under a loading piston, where pressure is applied and the sample remains until the resin cures. Bonds made in this way are extremely clear, free of bubbles, and introduce zero-dimensional error into the machine section thickness control procedures. Logitech bonding jigs are available for large or small-scale operations and have the capacity to hold large or multiple specimens. Here, we are utilising the BJ12, which has two sets of 6 loading pistons on either side of the central line to accommodate larger sections if required. Once the sample has been safely bonded to the slide, the excess sample material must be trimmed to prepare for the final lapping stage. The thinned rock sample should be as thin as possible to reduce lapping time and the cut kept to the highest possible quality to reduce subsurface damage. The GTS1 allows users to trim samples to as thin as 300 microns, increasing productivity. The functional system allows for automatic operations for the thinning of mounted samples. The samples are held in place by the vacuum chuck face slide holder, which is mounted onto the sample table. The slide holder passes parallel to the saw blade at a user adjustable distance, allowing slide thickness variation and rock slice thickness. The variable speed linear drive system and feed rate monitor on the GTS1 allows the operator to control the rate at which samples move through the cutting process, avoiding many of the problems associated with gravity-fed systems such as material shattering. The operator can set the optimum rate for the material being cut via the saw's user-friendly control panel, ensuring subsurface damage is minimised. The cut sample is now ready for the final lapping stage on the PM6. The slides will be mounted upon a Logitech precision jig. The slides are held by vacuum onto the chuck face, where they will be securely kept flat throughout the process. The vacuum chuck face also has an adjustable step height for high levels of accuracy. The precision jig is then mounted upon the cast iron plate for machine lapping, with specimen material being eroded away, resulting in low damage and smooth surface finishes. The final stage in the production of geological thin sections is to polish the specimens, although this is not always required. For this stage, we use the Logitech WG6 polishing system, comprising of a PM6 lapping and polishing machine and a WG6 polishing head. This system is capable of producing the desired finished sample to a very high standard. This can be high reflectivity, low relief, ultra-flat surfaces, or minimal edge roll-off. This highly versatile system can polish a batch of up to 6 samples at one time, or individually using a variety of sample holders. The WG6 offers a wide range of facilities, including variable and carousel speed and rotational direction. The powerful low-voltage motor provides sufficient torque to rotate the fully loaded carousel at a speed of up to 35 RPM. Incremental loads of up to 1.4 kilograms may be placed on each individual drive rod to assist with the polishing process.